Okay guys, we are going to learn how to calculate speed today. We are going to work with using a STD triangle. This is going to be for speed equals distance divided by time. So the triangle is going to help you solve your math problems.
Yeah, the triangle is just a way to put the formula, which is speed equals distance divided by time, into a format that you can really easily put in the numbers, and then it'll show you exactly what to do.
Okay, so let's try some practice problems. The first one, Mariah walks 150 feet from science class to math class at the end of second period. It takes her 3 minutes because she talks to all her friends. What is her average speed? So I have underlined the important information as we read through the problem. We're going to set up our STD triangle. All right, and what does 150 feet tell me? Is that speed, distance, or time? That's our distance. 3 minutes, that's our time, and speed is S. So we're looking for S. I'm going to go ahead and plug that into my triangle. And now I need to put my 150 in for my distance and 3 for my time. All right. Whenever one is on top and one is on bottom, we divide.
And it also shows it right here, the little division symbol.
So we're going to take 150 and divide by 3. So 3 will go into 15. How many times? 5 times. 5 times 3 is 15. We subtract and get 0. Bring down my other 0. 3 will go into 0, 0 times, and that's 0. So my answer is 50. But what about my units? We get our units for speed for distance divided by time. So it'll be feet divided by minutes. 50 feet per minute. Okay, let's take a look at number 2. Number 2 says bus 44 takes 2 hours to complete its route at an average speed of 20 miles per hour. What is the distance it travels? Okay, so 2 hours told us our time, and 20 miles per hour tells us our speed, and we're looking for distance. So we're going to create our STD triangle with the information we're given. All right, we know our 2 hours is our time. It goes in the bottom right corner. Our speed goes on the bottom left, and we're looking for distance. All right, when they're side by side, we multiply. So we're going to take 20 times 2. Okay, so 2 times 0 is 0, and 2 times 2 is 4. So our answer is 40, but we need our units for distance. To find our units for distance, we look back to our average speed, because average speed is distance divided by time. So our distance is in miles. So 40 miles is our answer. All right. Now we're going to work the last one, number 3. Jessie's family is traveling to Houston to visit her grandmother. The distance is 210 miles, and they are traveling at an average speed of 70 miles per hour. How long will the trip take? Okay, so it said that our distance is 210 miles and our speed is 70 miles per hour. We need to figure out the time. So let's draw our STD triangle. We are looking for T, our time. Our distance on top is 210, and our speed was 70. Again, top and bottom, we're going to divide. All right, so 210 divided by 70. All right, so 70 cannot go into 2. 70 cannot go into 21. 70 can go into 210. How many times? 3. 3 times 0 is 0. 3 times 7 is 21. We subtract and get 0. So our time is 3, but what are our units? We have to look back at our speed because our speed is distance divided by time. Distance per time is hours. So our answer is 3 hours. Now that we've shown you how to use your STD triangle, you're going to do some practice problems using it to solve for the missing variable. So your instructions for this assignment is to draw an STD triangle for each problem. You're going to replace the variables with the numbers provided in the problem. So for example, 2 of the variables in your triangle will be given to you, and you have to solve for the third one. Make sure you show all of your work and then include your correct unit with your answer. All right, so I'm going to help you set up problem number 1. So we're going to say Marty walked 270 yards in 3 minutes. What was his average speed? Okay, so yards tells us distance, minutes tells us time, and we're looking for speed. So you're going to draw your triangle. All right, and then you're going to plug in the information that's given and solve. All right, don't forget that your units for speed is distance divided by time. So yards per minute.
Okay, let's take a look at this graph. This is called a distance time graph because there's distance on the y-axis. This is measuring distance, and this one says kilometers. And then on the x-axis is time, and in this one it's hours. Now when you look at a distance time graph, you can determine a lot about the motion that's going on the object without even looking at the numbers. Okay, for example, the first segment of this graph is very steep. When you see a very steep segment of a graph, that tells you that the motion is very fast, okay? And you can think about it like if you rolled a marble down it. If you rolled a marble down this slope, it would be very fast. It would go down fast, okay? The next segment of our graph is actually horizontal. In other words, the distance is not changing in this amount of time right here. So if the distance is 0 at the beginning and the end, then that means the object actually didn't move at all. So if the graph is horizontal, that means there's no motion, the speed is 0. Think about your heartbeat. If you're flatlined, you're not moving because you're dead, okay? So it's the same thing. When you have a flat line, horizontal line, there's no motion. Okay, this next section of the graph right here, it is not very steep. It's pretty flat, but it's not completely flat because you can see the distance changed a little bit. Okay, when the distance changes just a little and you have a pretty flat line, but it's not completely flat, that means the speed is very slow. Think again about your marble. If you rolled your marble down here, it wouldn't go nearly as fast as it would over here. All right, so this is indicating slow speed. All right, here's another section that's horizontal or flatlined. So if it's horizontal, that means that between here and here, the speed is 0. And then this segment, it is not as steep as our beginning segment, but it's steeper than our middle segment. So the speed is kind of a medium speed. All right.
For our next activity, you and your table partner are going to do a card sort where you match a storyline to a distance time graph. Okay, so for example, on my first card, you read the story. It says a horse raced quickly down the track at a constant speed. So if you're going at a constant speed, you know it's going to be one solid line. And it said he's going quickly. So that tells us that our line is going to be very steep. Okay, so if I were to roll a marble down this line, it would go really fast. So if I take a look at all of my graphs, Make sure your 0 is in the bottom left corner of your graph, so they're pointing the right direction. I need to match this card to a graph. Okay, so I'm looking for one that is a straight line by itself. That leaves this graph and this graph. Okay, which of these two graphs shows me that something is moving quickly? The one that's steeper. That means this one matches my story. Okay, you and your table partner are going to take the rest of the stories and match them to the graphs. All right, now we're going to do some practice problems using our graph. This graph shows the movement of a snail over a 6-minute period of time. So with this information, we're going to be calculating average speed. All right, on a graph, whenever you're calculating out average speed, you need to take the ending distance and the ending time and subtract them from their beginning distance and beginning time to get your average. So I'm going to write that formula down for you. So our average speed equals our ending minus our beginning distance divided by our ending minus beginning time. Now I'm going to explain that to you and show you how to do that in your problems here. And you have to do that before you plug in the numbers into your STD triangle. Okay, so number 1 says, what was the snail's average speed after 2 minutes? Okay, so we take a look at our graph. Our graph starts at 0, 0, so that's our beginning time and our beginning distance. All right, and at 2 minutes right here, our point is at 20 centimeters in distance. That's our ending. All right, so we take our ending distance, 20 centimeters, and subtract it from our beginning, which is 0, and divide it by our ending time, which is 2 minutes, minus our beginning time, which was 0. So we take 20 minus 0 is 20 centimeters, and our time is 2 minus 0, which is 2 minutes. So now I have my distance and my time. I can now plug those into my STD triangle. Okay, so here's my STD triangle, and I'm looking for speed. So I plug in my S. My distance goes on top, and I'm going to be dividing by the time on the bottom. Remember, top and bottom divide. So what is 20 divided by 2? Well, 2 will go into 2 one time. You multiply, get 0. Bring down our 0. 2 will go into 0 0 times. 0 times 2 is 0. We have our answer of 10. But what are our units for 10? All right, we have 10. Our distance was centimeters per time of minutes. So 10 centimeters per minute is our average speed of our snail after 2 minutes. Okay, now taking a look at number 2, it says, what was the snail doing between 2 and 4 minutes? So we return to our graph. Here is time 2 to time 4. Well, what do we know about a flat horizontal line? That means that it's stopped. Okay, so something happened to our snail and he stopped. So if we wanted to show how this works by doing math, we would take our ending measurement. We start with distance, so our ending is 20 centimeters, and we subtract our beginning distance, which was 20 centimeters, and we divide it by our ending time minus our beginning time. So our ending time was 4 and our beginning time was 2. Okay, so we would get that for our distance and our time. Okay, so again, it shows you that it went nowhere in 2 minutes time. So it stopped.
And then what would the speed be if it went nowhere?
Its speed, whenever you calculate this out, would be 0. That speed was stopped. So think of a car. Whenever your car is stopped, your speed is at 0. So that would be 0 centimeters per minute for our speed. Okay. Now let's take a look at number 3. We're going to go back to calculating out average speed, but this time after those 4 minutes. All right, so our average speed between time 0 and time 4 would be what? Well, we take our ending distance at time 4 is 20 centimeters, and we subtract our beginning distance. Our beginning distance at 0 was 0, and then we divide. Our ending time was 4 minutes because it told us after 4 minutes, and our beginning time was again at 0. All right, so we have 20 centimeters over 4 minutes. That is our distance and our time. Now we can plug it into our STD triangle. We're looking for speed, so I plug that one in. My distance goes on top, and my time goes on bottom. When it's top and bottom, we divide. So 20 divided by 4. How many times will 4 go into 20? 5 times. 5 times 4 is 20. We subtract and get 0. So now I need my units again for my number. For speed, it is distance over time, so centimeters per minute. 5 centimeters per minute is our average speed after 4 minutes.
It makes sense that it's slower than your first average speed because half of this time, what was your snail doing? He was resting, he wasn't moving. So for half of the time he wasn't moving, half of the time he was. That makes your speed slower.
Okay. Now taking a look at number 4. What was the snail's average speed between 4 and 6 minutes? Okay, so between 4 and 6 minutes, we're only looking at that part of our line graph. Okay, so again, we take our ending distance. So at time 6, what was our distance? 60 centimeters. So 60 minus what was our beginning distance at time 4, because we're only looking between 4 and 6. So our distance at time 4 was 20 centimeters over our ending time. So at our end time of 6 minutes minus our beginning time of 4 minutes. Okay, so 60 minus 20 is 40 centimeters over 6 minus 4, 2 minutes. Okay, so this gives us our distance and our time. And now we can plug it into our STD triangle. All right, so let's take a look at plugging it in. We're looking for speed again. Our distance goes on top. Our time goes on bottom. Top and bottom, we divide. So we take 40 divided by 2. 2 will go into 4 how many times? Twice. 2 times 2 is 4. All right. 4 minus 4 is 0. Bring down my 0. 2 will go into 0. 0 times 2 is 0. Okay, so we have our speed of 20. We need to write our units. So 20 centimeters per minute. This is our average speed only for this part of the graph. Okay, and if you take a look at your graph, our first measurement was the average speed of this part. It was slower than this part. Okay, and if you're looking at your graph, which one is more steep? This one. This one's faster. It's got a steeper graph, so that's why we knew our answer should be bigger than the speed we got for the first segment. Okay? Now it wants to know on number 5, what is the snail's average speed for the entire period of time, for the whole 6 minutes? Okay? So we're going to start at time 6. What is our ending distance? Our ending distance is 60. And our beginning distance was 0 over our ending time, times 6. And our beginning time was 0. 60 minus 0 is 60 centimeters. And 6 minus 0 is 6 minutes. So now we have our distance and time, and we can plug that into our STD triangle. So I draw my triangle. Again, we're looking for S. My distance goes on top, my time on bottom. Top and bottom, they're different, so I divide 60 divided by 6. 6 can go into 6 one time. 1 times 6 is 6. I subtract, get 0, bring down my 0. 6 can go into 0. 0 times 6 is 0. I get 0. So my answer is 10. I need to add my units for speed. 10 centimeters per minute. This is my average speed for the entire graph. Okay?
Okay, now for your last part of your assignment. You're going to interpret a motion graph. All right, and here's the scenario that we're looking at with this graph. It said, Ashanta wore her Fitbit during PE today. After class, when she checked the Fitbit app on her phone, she saw the following graph of her motion. Now you need to match each section of this graph, the A, the B, C, D, and E, with a description from the table below that best describes the motion for the section. So you read the description, and then you figure out which one of these sections that it's talking about. Okay? Now remember from what we've already talked about, if the graph is steep, she's moving fast. If the graph is not very steep, it's pretty flat, she's moving kind of slow. And if it's completely horizontal, flatlined, she's not moving at all. So use that information, read each one of these sections, and then write the letter for which part of the graph it belongs to.